Okay, I'm back. I had to do a new video because it locked me out of it. Anyway, so this first one that we looked at has a positive correlation because as x increases, so does y. If I take a look at this one, while x is increasing, y is steadily decreasing. So this one I can say has a negative correlation. And if you think about it, if I were to draw a line through this, as best I could, draw a line through that, this would have a negative slope. This one, on the other hand, if I drew a line through it, it would have a positive slope. So positive slope, positive correlation, negative slope, negative correlation. Now, if I take a look at this one down here, these dots are all over the place. If I drew a line through this, it would get some of them, but then if I drew a line that way, it would get some of them. So it doesn't look like these two quantities, whatever they are, have anything to do with each other. So if our scatter plot looks like this, where they're all over the place, I could say that this has no correlation. These two quantities don't relate to each other. So if I had to give examples of these, positive correlation. As you work more, you get paid more. As one increases, so does the other. Something that would increase on the x yet decrease on the y, I could say if I take money out of my account every month, as the months increased, the amount in my bank account would decrease. Now, going along with no correlation, these are two things that have absolutely nothing to do with each other. If I'm measuring the amount of milk in my fridge versus the amount of hair that my dog sheds, these two things don't have anything to do with each other. That's why they're all over the place. So, next thing we're going to do, and I'm also going to be putting, this is going to be a glue in as well. I'm going to be putting number 2. And the one that you're going to be gluing in looks like this. Alright, so I've glued it in. Looks something like this. So this table is showing altitude versus temperature. Now there are two ways that you can do this. The first way I'm going to do it is I'm going to graph it. If you don't have graph paper at home, just do your best by drawing one. So I'm going to draw just quadrant 1, because again, these scatter plots are mainly going to be taking place in quadrant 1. So I'm going to take a look at my altitude and my temperature. So I'm thinking that temperature is dependent on the altitude. So my altitude is going to go along my x-axis, and my temperature is going to go along my y-axis. Now, altitude looks like it's going up in increments of about 500. Actually, it's going up exactly in increments of 500. So that is how I'm going to do the scale on my x-axis. So this is 0. And we're going to do 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, whoops, 4,000, I can't write, 4,500, and I should have made this bigger. I always should make it bigger, and 5,000. Okay, so there is my x-axis, and this is the altitude, and the variable that they're giving it is m. So temperature doesn't really look like it's going down in a particular amount. So I'm just going to do it by, tens. I think that's my best guess here. Yep, I'm just going to do it by tens. So I'm going to say 10, 20, 30, 40, 50. What's my highest one? My highest one is 63. So I'm going to go to 60 But then I'm going to go, I always should make my graph bigger. I'm going to go up to 70 as my final one because 61.3 is my highest value right here. So I always want to go up one higher than my highest. So what we're going to do is we're going to plot each of these. And we're going to see what kind of correlation altitude and temperature have with each other. If they have a correlation, they may not have one at all. So we have 0 here. We're going to go 0 and then 59. So just beneath this guy, 559.2. So pretty much right next to him. 1061.3. So just above. 1555.5, so right in here. 2041.6, right about there. 2529.8, so just under the 30 mark. 3029.9, so basically right next to them. 3,518 and 1/10, right about here. 4,026 and 2/10, right about in the middle. 4,512.4, right about here. And 5,000, oh boy, 6/10. Okay, so almost right on top of it. Okay. Now, is it a perfect straight line? No. Scatter plots are not going to be perfect straight lines. But if I take a look at it, the general direction that it's following seems to be in the negative direction. Think about it. If I drew a line straight through this, it would have a negative slope. So this here has a negative correlation. So if I were to say that in words, I could say as altitude increases, temperature is decreasing. All right. Next thing that we're going to take a look at is what we call a trend line. Remember how I was saying if you were to draw a line through it, it would have a negative or positive slope? That's kind of like what a trend line is. You're trying to find a line that best fits what the data is showing you. So before we get started, we're actually going to write that into our notes. Trend line, or it is sometimes called a line of best fit. Notice these two words, best and fit. The line that you make is not always going to perfectly match up with every single data point. You're just doing the best that you can. You want to get at least two data points on that line. If you can get more than that, great, but you always want to get 2 points. So before we get started, let's go ahead and write this in. So trend line or line of best fit. It is an equation. Typically in slope-intercept form, so y equals mx plus b. Not always, but usually. It's an equation to show a line that fits as much of the data as possible. And we're going to add this on as well. Should go through at least 2 points from the table. So just like we had a table for this one and we made a trend line, you're going to be given a table that has a whole bunch of data in it, and you want to make sure that your trend line or line of best fit goes through at least 2 of those points. So we're going to go ahead and do one of those. I put 2 for that one. Hang on, let me fix that. Be right back. Okay, I fixed it. Now that's 1, now that's 2, and we're good to go. So we're going to go ahead and glue in the next piece that we have here. should look something like this. We're talking about a panda. Go ahead and glue that in. I'll do that now and I'll be right back. Okay, I'm back and now it's glued in. Alright, so what we're going to do is we're going to graph this just like we did the other one, except this time we're going to figure out an equation that fits this data the best that it can. It's not going to represent every single data point we have on here because remember, we are imperfect. Maybe in a perfect world, all of these data points would lie exactly on the line that we are about to create, but, you know, humans are imperfect. So we have a line of best fit because we're doing the best that we can. All right. So it looks like we're comparing age with weight. I'm going to say age is going to be our independent variable. Weight is going to be our dependent variable. So age is going to go down along, oh, I can't spell today. Age and weight. All right. So age is going up. It skipped some. That's okay. I'm going to put it on there anyway. I'm just going to count up 1 through 12, talking in months. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Why do I always make my graph too short? 10, 11, and 12. All right. Weight is, it looks like it is increasing, but it's increasing differently. So I'm going to go up, I'm just going to go up by 5s. So I'll start here, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and I never make it big enough. Oh, no, wait, I did this time. Go me. Okay. So let's go ahead and plot these data points. So at 1 month old, this thing weighs 2.5 pounds. At 2 months old, it weighs 7.6 pounds, so right about there. At 3 months, 12.5, right around there. At 4 months, 17 1/10, so here. 5 months, so we don't have one for 5 months. We do have one for 6 months, 24.3. Maybe they skipped a month. See, they're imperfect. They skipped one. Nothing for 7. We do have an 8, 37.9 here-ish. We don't have a 9. We have a 10 at 49. So right about here. And then we don't have 11, but we do have a 12. So right about here. Okay. So perfect straight line? No. But you can see that this does have a positive correlation. Now, here's what I'm going to do. Remember how I said your trend line or line of best fit should go through 2 points? Well, here's how we're going to start. We're going to pick 2 of the points off of our table. It doesn't matter which 2 you pick, but I would say pick one that's towards the beginning of the graph and one that's towards the end of the graph. Don't pick 2 that are like right next to each other. Try to like spread it out. So I'm going to go with my first and my last. All right, gonna go with those 2. So what are we going to do with these 2 points? Well, we need to be able to figure out a line that can represent as much of the data as possible. What do we need when we are figuring out a line? Well, if we're doing it in slope-intercept form, as most trend lines are written, we need a slope, we need an intercept. Hey, we've got 2 points. We can figure out both of those things. Let's do slope first. So my 2 points here, and I'm just going to write them to look like coordinates, are 1 and 2.5, 12 and 54 9/10. So I'm going to take these 2 points and I'm going to go ahead and calculate slope. So remember, slope is always y1 minus y2, or sorry, y2 minus y1, forgive me, over x2 and x1. Okay? So when I go ahead and figure out my slope, I'm going to grab my calculator. 59.4 minus 2.5. I get 52.4 over 11. Now, this is the only instance where I will say it is okay to use a decimal instead of a fraction in your slope-intercept form. The only occasion. So once I divide that, I get a slope of approximately, and I'm just going to round to the nearest tenth here, this should be 4.8 is what you get, which makes sense because if I had 44 divided by 11, it would be an even 4. This is a little higher, so it makes sense that that should be higher as well. Okay, so we have the first part of our trend line. But we need the second part. We need the intercept because that tells us kind of where our graph begins. So what I'm going to do is I'm going to pick one of the points that I used for slope, and I'm going to plug it in for x and y, and that will tell me my intercept. I'm going to go ahead and use this one. It doesn't matter which of the two you use. You might get something slightly different from somebody else, but remember, we're trying to find the line of best fit. Your line might look a little bit different because maybe somebody else used two different points. But at any rate, I'm going to start and I'm going to use this one. So I'm going to plug in 54.9 equals 4.8 times 12 plus b. Okay, so plugging it in there, I get, let me put in my calculator, 54.9 equals 57.6 plus b. We subtract from both sides the 57.6 because we want to get b by itself, and we get negative 2.7 equals b. Okay? So my equation is going to look like this. So my intercept, and I guess this kind of makes sense because if you take a look at it, if I was to run a straight edge right through this, it looks like it would be down here somewhere. But just out of curiosity, I'm going to go ahead and see what happens if I plug in my other point, because my intercept might look a little bit different. So instead of using 54.9 and 12, I'm going to try the 1 and 2.5. So I'm just going to put a little divider line to show that this is something different. So y equals 4.8x plus b. So 2.5 equals 4.8 times 1 plus b. 2.5 equals 4.8 plus b. Subtract that from both sides, and we get negative 2.3 equals b. So then this equation, if I had used a different point, is going to look something like this. Pretty close. Not that far off. So what this would mean is, I guess, he's 0 months old. They're not calculating his weight when he's, still in his panda mommy's belly. Which I guess makes sense. They can only weigh him when he's outside of his mommy's belly. That's why it starts here at 1 month and not at 0. All right. So once I've done that, what I'm now going to do is draw a line connecting the 2 points that I used. So I used 1 and 2.5 and 12, 54.9. So you want to go ahead and grab yourself a straight edge. You can use a ruler or the edge of your book, doesn't matter, but you're going to go ahead and connect those 2 points. I'm going to go grab a straight edge and then I'll be right back. Okay, I'm back. I grabbed this weird envelope thing. So the 2 points that I'm using are right here and right here. So I connect them best I can. Now if I hit other points on here while I'm drawing this line, that's great. But remember, our line of best fit should really just go through 2. Now I put an arrow on the end. Why? Because he's going to keep getting older. He's going to keep gaining weight. However, if we were to follow this line out, like let's say we're still collecting data as he gets to, 2 years old, 3 years old, 4 years old, this line is going to increase, but then it's going to start to taper off. Why? Because he's not going to keep gaining weight his entire life. He's not going to be the most obese panda in the world. No, he's going to get to, like his adult weight, and then he's going to stop. So this is a good representation of his weight, up to a year, but if we were to follow it, we would see that it would eventually stop. So that's where we're going to stop for this particular lesson, guys. Now, some of the questions in your homework are going to be asking about a graphing calculator. You can skip those unless you want to try them, because I don't think any of you actually have a graphing calculator. So just do the ones that are talking about correlation and the ones that are asking you to find the trend line or line of best fit. You can always come back to this video in order to help you, kind of guide you through those.